So now on your screen, so we have a topic heading, that is magnetic materials, derivation of Langevins theory of paramagnetic materials or theory of paramagnetism. It is a classical theory. So today's class is dedicated to classical theory of Langevins theory of paramagnetic material, and we are going to derive the steps very slowly. So the basic understanding of paramagnetic materials is paramagnetic materials have very small and positive susceptibility. Susceptibility of paramagnetic materials is positive, greater than 0. It is positive, whereas diamagnetic material it was negative. The susceptibility of paramagnetic material does not depend on temperature. It depends on temperature, whereas diamagnetic materials susceptibility does not depend on temperature. These paramagnetic materials, when brought near a magnet, they are slightly attracted by the magnetic field. And the important characteristic for paramagnetic materials is the presence of unpaired electrons. In paramagnetic materials, some of the electrons are unpaired, whereas in diamagnetic material, all the electrons are paired. So there are no net spin. So in paramagnetic materials, some electrons are unpaired. So which is the main reason for their magnetic property, paramagnetic property. And when placed in a magnetic field, the paramagnetic materials align parallel to the field, whereas diamagnetic material, they stand align perpendicular to the field. So a diamagnetic rod is placed between the pole pieces. If it stands parallel between the two pole pieces, then it is paramagnetic. So if it is perpendicular, then it is diamagnetic. That is the property of the paramagnetic materials. Now, let us assume that each atom has a magnetic moment m. We are starting the derivation, a magnetic moment m, and when it is placed in an external field B, the only force acting on these atom is the external field B. When you apply an external field, so you look at the figure, when you apply the external field, these atomic domains or magnetic moment, they align, making an angle theta inclination with the field axis. The atomic domain or the dipole, they make an angle theta with the direction of external field applied. Theta is the inclination to the magnetic field B. So when you apply an external field B, theta is the angle of inclination of atomic dipole with the direction of applied magnetic field B. That is the external field. Now, because of the presence of external field, there is a magnetic potential energy. So magnetic potential energy of this dipole is given by, in some books it is given as E. Now in this we are using U symbol. So E is also energy, U is also energy. So it is the magnetic potential energy U is equal to minus mb cos theta. This we are starting with this expression where theta is the angle of m. See, in the expression, magnetic potential energy of the diamagnetic pole which is placed in an external field of B, where its magnetic moment is m, B is the magnetic field. So U is equal to minus m is magnetic moment, B is magnetic field applied, theta is the angle of inclination, cos theta is the vertical. When you resolve in two components, sin theta horizontal, cos theta vertical. So cos theta is the vertical component. So potential energy U is equal to minus mb cos theta. And you can add a line here that this potential energy, how does it come? It is because of doing work done if we move a magnetic dipole from position of zero potential energy to any position, any angle theta. So if you go on changing the angle, so zero potential energy is, when is cos 0? When theta is equal to 90 degrees. So cos 90 will be 0. So the initial position from cos 90 degree to any angle cos theta. So if you write work done is equal to mb cos 90 minus cos theta. Cos 90 is 0. So that's how you get u is equal to minus mb cos theta. So minus mb cos theta hang bartu andre. So it is work done in moving from zero potential energy to any inclination theta. So therefore work done is the energy. So that is equal to mb cos 90 minus cos theta. So that is cos 90 is 0. So therefore the energy is equal to minus mb cos theta. Now we'll move further. In the paramagnetic material, there are, suppose, n number of atomic dipoles, and according to classical Boltzmann statistics, so we are using one expression from Maxwell-Boltzmann statistics, right? From that, we are directly writing the total number of such atomic dipoles which are inclined within the angle theta and d plus theta. So within an angle theta and theta plus d theta, so it forms a cone. So if you imagine 3 dimension, it is like a cone subtended with the field axis, so which we will be further calling it as a solid angle. So this expression, or total number of atomic dipoles inclined with the field axis in the range theta and theta d theta, is given by the important first expression is dn. That number is equal to a constant c e to the power m b cos theta by kt into sin theta d theta. So this is the basic expression. So I have few more lines. How will get this expression? Adunu ಹೇಳ್ತೀನಿ ಹೆಂಗ್ ಬಂತು ಅಂತ. So first concentrate on the expression. The total number of atomic dipoles in the range theta and d theta is dn. That is c is equal to exponential factor e to the power mb cos theta by kt or mb by kt cos theta into sin theta d theta, where k is Boltzmann constant, t is absolute temperature, theta is inclination, m is magnetic moment, b is field, and c is any constant of proportionality. So we'll just see how we got this expression, and from this rest is very simple. So how do we get this expression? So I have explained in these lines. From classical Maxwell distribution function, atomic dipole making an angle theta with the field direction is given by a exponential factor e to the power minus e by kt, right? The distribution function gives, it is a direct, it's like a tool, it gives a classical distribution function. It says that the atomic dipoles making an angle theta with the field are given by e to the power minus e by kt, where e is the energy. So in this case we are using e as u, therefore it is same as e to the power minus u by kt, where e or u is the energy of the dipole, k is Boltzmann constant, t is the temperature. Further, if the paramagnetic material contains n number of atoms per unit volume at a particular temperature T, magnetic moment m, then dn is proportional to exponential Boltzmann factor, that is e to the power minus u by kt into the solid angle, that is between theta and d plus theta. So dn is proportional to e to the power minus u by kt into d omega, where d omega is the solid angle which is defined by 2 pi sin theta d theta. So which is like a cone making an angle theta, that d omega is given by 2 pi sin theta d theta. Therefore, dn, if you remove the proportionality sign, so you get dn is equal to c is a proportionality constant e to the power minus u by kt into d omega. Next step for d omega and u. So you know that u is minus mb cos theta by kt from our earlier expression. U is minus mb cos theta by kt and d omega is 2 pi sin theta d theta. Suppose if you substitute these two, now that dn, d it should be small n. So this dn, it becomes proportional times ce, there is actually minus u and mb cos theta is also minus. Therefore, this term becomes positive. ce raised to plus mb cos theta by kt. Okay, ಅದು ಯಾಕೆ ಪ್ಲಸ್ ಆಯಿತು ಗುರ್ತೈತಲ್ಲ? ಸೊ e to the power minus u by kt ಅದ. And also u is also negative, minus mb cos theta. So minus minus plus ಆಗ್ತದೆ. Therefore, dn is equal to c e to the power mb cos theta by kt into d omega is 2 pi sin theta d theta. So therefore, the expression which we have written directly, that is dn is equal to c e raised to mb cos theta sin theta d theta. 2 pi is also taken in a constant c. 2 pi can be added to constant c. So therefore, it is dn c e raised to mb cos theta sin theta d theta. Okay. Now put in the expression mb by kt. See, we are simplifying this equation further. mb by kt we have put it as alpha. Therefore, the dn expression becomes c e raised to mb by kt alpha itu. So dn is equal to c e raised to alpha cos theta sin theta d theta. 2 pi also taken into the constant. Constant nang include madivi. So it is c e to the power alpha cos theta into sin theta d theta. So this is the important expression. Now, so total number of atomic magnets in unit volume. So in unit volume of paramagnetic material, so therefore we have to integrate between the limits 0 to pi. So n is equal to 0 to pi dn. So whatever dn expression we have taken, so this is between theta and d theta. So for all the atomic magnets in the range 0 to pi, we have to integrate this expression, dn expression, that is c e raised to alpha cos theta sin theta d theta. And we proceed by further simplifying. We put this cos theta as x. Okay, we simplify putting cos theta as x. Then if we take dx, it is minus sin theta d theta. Okay, cos theta we have substituted as x, then dx will be minus sin theta d theta. These two will substitute back in the previous equation for n, that is integral 0 to pi c e raised to alpha cos theta is x and sin theta d theta is minus, that is dx with a minus sign. Sin theta d theta can be minus dx. Minus sin theta d theta is dx. So we want sin theta d theta, it can be minus dx. So the expression becomes 0 to pi c e raised to alpha x minus dx. And the limits, you can see that cos 0, see, put theta is equal to 0, lower limit, it becomes plus 1. Put cos theta, upper limit pi, it is minus 1. Therefore, n is equal to 0 to pi becomes plus 1 to minus 1 minus dx sign is minus c e to the power alpha x dx. This has been become very simple exponential integration. Simple formula itiga. So plus 1 minus c e raised to alpha x dx. Okay. Next, we change the limits. This minus sign is removed by changing the upper and lower limits. So upper limit is made +1, lower limit is made -1. Therefore, this minus sign goes. C is a constant. We have taken outside integral C into -1 to +1 e raised to alpha x dx. Okay. Integration of exponential e raised to alpha x dx. Negative sign ಯಾಕೆ ಹೋಯ್ತು ಅಂದ್ರೆ ಲಿಮಿಟ್ಸ್ ಚೇಂಜ್ ಮಾಡ್ಕೊಂಡಿವಿ. ಲಿಮಿಟ್ಸ್ ಚೇಂಜ್ ಮಾಡಿವಿ, +1 ಕೆಳಗಿಂದು ಮೇಲಿಂದು ಚೇಂಜ್ ಮಾಡಿವಿ. ಸೊ ಹೋಯ್ತು, ಸಿ ಕಾನ್ಸ್ಟಂಟ್ ಅದ, ಹೊರಗೆ ಬಂತು. ನಾವು ದಿಸ್ ಇಂಟಿಗ್ರಲ್ ಈಸ್ ಸಿಂಪ್ಲಿಫೈಡ್ ಆಸ್ ಇ ರೇಸ್ ಟು ಅಲ್ಫಾ ಬೈ ಅಲ್ಫಾ. ಇಟ್ಸ್ ಇಂಟಿಗ್ರೇಷನ್ ಏನಾಗ್ತದೆ, ಇ ರೇಸ್ ಟು ಬೈ ಅಲ್ಫಾ ವಿತ್ ಇನ್ ದ ಲಿಮಿಟ್ಸ್ -1 to +1. ಅವು ಸಬ್ಸ್ಟಿಟ್ಯೂಟ್ ಮಾಡಿದಾಗ n is equal to c constant into e raised to plus alpha minus e raised to minus alpha divided by alpha bantu. Integration value of exponential and substituting the limits, n is equal to c is constant e raised to plus alpha minus e raised to minus alpha divided by alpha. And rearrange ಮಾಡಿ we want to substitute for c. Therefore, c is equal to alpha ಈ ಕಡೆ ತೊಂಡ್ರೆ n alpha ಆಯಿತು. So n alpha divided by e raised to alpha minus e raised to minus alpha. ಇದು ಡೈರೆಕ್ಟ್ ಸ್ಟೆಪ್ ಕೊಟ್ಟ ಬುಕ್ ಒಳಗೆ. ನೀವು ಯಾರನ್ನ ಬುಕ್ ರೆಫರ್ ಮಾಡ್ಲಿಕ್ಕೆ ಡೈರೆಕ್ಟ್ c is equal to n alpha by e raised to alpha minus e raised to minus alpha ಅಂತ ಕೊಟ್ಟಾನೆ. ಸೊ ಇದು ಹೆಂಗೆ ಬಂತು ಅಂದ್ರೆ n is equal to ಬರೆದು ರೀಅರೇಂಜ್ ಮಾಡ್ರಿ, ಇಂಟಿಗ್ರೇಷನ್ ಮಾಡಿ. So now c is equal to n alpha by e raised to alpha minus e raised to minus alpha. ಈ ಸ್ಟೆಪ್ ತನ ಬಂದಿದೆ. So now further, the component of dipole which is parallel to the field is m cos theta, because the vertical component ನಿಮಗೆ ಹೇಳಿದ cos sin horizontal ಇರ್ತದೆ, cos vertical ಇರ್ತದೆ. So therefore the component which is parallel to the applied field is m cos theta. The total magnetic moment of all n atoms contained in unit volume is magnetization. So therefore m, capital M is magnetization, small m is magnetic moment. ಅಷ್ಟು ಡಿಫರೆನ್ಸ್ ನೋಡ್ಕೊಂಡ್ರೆ ಅಂದ್ರೆ ಪ್ರಾಬ್ಲಮ್ಸ್. ಸೊ m is magnetization, which is the total magnetic moment of all n atoms in unit volume. That is magnetization. So that m is equal to 0 to pi m cos theta, which is the component which is parallel to the field m cos theta, and dn for all the dipoles. So m magnetization is 0 to pi m cos theta dn. So dn from earlier expression, that is 0 to pi m cos theta as it is, dn is c e raised to alpha cos theta sin theta d theta. So dn from previous expression, so we have substituted. Now once again we put cos theta equal to x minus sin theta d theta equal to dx. So this equation is simplified. M is equal to limits +1 to -1 minus mx, that is cos theta is x, c e raised to alpha cos theta is x, and dx. So this is equal to c and m are constant, so we have taken outside, and the limits we change to change the sign. Minus ಇದ್ದಿದ್ದು ಪಾಸಿಟಿವ್ ಮಾಡೋ ಸಲುವಾಗಿ ಮತ್ತೆ ಲಿಮಿಟ್ಸ್ ಚೇಂಜ್ ಮಾಡ್ತೀವಿ. -1 to +1, c and m are constants, we have taken outside, that is x into e raised to alpha x dx. Now we have, it is integration by parts. So we have two parts, x is also there, e raised to alpha x is also there. So therefore we have to integrate it by parts and substitute the value of c. C value ಏನದ n alpha by e raised to alpha minus e raised to minus alpha. ಅವೆಲ್ಲ ಸಬ್ಸ್ಟಿಟ್ಯೂಟ್ ಮಾಡಿದ್ರೆ ನಮಗೇನು ಬಂತು, m is equal to, capital M is equal to m small n into the bracket e raised to alpha plus e raised to minus alpha divided by e raised to alpha minus e raised to minus alpha minus 1 by alpha. This is after integrating by parts, the integral -1 to +1 x e raised to alpha x dx integrate by parts ಮಾಡಿದ್ರೆ ನಮಗೆ ಇದು ಬರ್ತದೆ. ಆಮೇಲೆ c also we have substituted from the earlier expression. So M is equal to, that is magnetic moment M, magnetization capital M is equal to small m is magnetic moment, N is total number of dipoles into the bracket e raised to alpha plus e raised to minus alpha divided by e raised to alpha minus e raised to minus alpha minus 1 by alpha. So in this expression, so you also see that the expression, there is an hyperbolic function e raised to alpha. So listen carefully, e raised to alpha plus e raised to minus alpha divided by 2 and e raised to alpha minus e raised to minus alpha divided by 2 are sin alpha hyperbolic, sin h and cos h, they are hyperbolic functions. So sin h and cos h, their ratio, that is cos, that is e raised to alpha plus e raised to minus alpha divided by 2 is cos hyperbolic alpha, cos h alpha, divided by e raised to alpha minus e raised to minus alpha divided by 2 is sin h alpha. 2 cancel ಆಗ್ತದೆ. So e raised to alpha plus e raised to minus alpha divided by e raised to alpha minus e raised to minus alpha is cos hyperbolic by sin hyperbolic, therefore it is cot hyperbolic. Ali direct cot h ant kottanu book olaga. So that is how you get it as cot hyperbolic alpha minus 1 by alpha. So this is a very important step in the derivation. Illi tana bandre aaytu, innondu 2 ನಿಮಿಷ ಮುಗಿತು. So magnetization M is equal to M into N cot hyperbolic alpha minus 1 by alpha. This function, that is in the square brackets, cot hyperbolic alpha minus 1 by alpha is known as Langevin function. So in this important step, this bracket cot h alpha minus 1 by alpha is a Langevin function. So this is how it varies, that we'll see in the graphically, we'll discuss how this Langevin function varies. So we have derived up to this step, magnetization M is equal to, small m is the magnetic moment, N is the number of dipoles, L alpha is the Langevin function, which is equal to the bracket cot hyperbolic alpha minus 1 by alpha. We are substituting it as L alpha. So this L alpha is the Langevin function. So see how this magnetization varies with alpha. How magnetization varies with alpha. First case, when the temperature is very low, applied field is large, then L alpha tends to 1. That is Langevin function, it tends to 1. It is not equal to 1, but it tends to 1 when temperature is low, at very low temperature and field is large. So if you look at the graph, so you know that the magnetization and alpha, then after certain value of magnetization, there is a saturation. There is a saturation. It is almost equal to Mn because L alpha becomes 1. It is almost 1. Therefore, magnetization equal to Mn with the dashed line. So in all other case, there is a linear relation. So it increases up to certain point. There is variation of Langevin function with alpha or variation of magnetization with alpha with a critical point when L alpha tends to 1, Langevin function becomes 1. So magnetization becomes Mn, that is saturation. Now, this saturation is because of all the atomic dipoles are aligned parallel to the field. So that is the property of paramagnetic materials. So second case is important. Under normal condition, that is when the temperature is not very low, field is there, alpha becomes very small. Alpha is small. Therefore, Langevin, approximately Langevin function L alpha becomes alpha by 3. Cot h alpha minus 1 by alpha becomes alpha by 3. Approximately Langevin function becomes alpha by 3 under normal conditions. Therefore, M magnetization is M into Mn into alpha by 3. L alpha is alpha by 3. So substituting for alpha, that is Mb by Kt. So this expression becomes N. M is already there and for alpha it is mb by kt. So it is n m square b by 3 kt. And also substituting for b is mu naught h. B is mu naught h. So susceptibility is defined as m by h. It is the ratio of magnetization to the inducing field, magnetizing field, inducing field. So susceptibility is represented by chi, chi. So it is a slanted x or curly x equal to capital M by capital H. M from the earlier expression is m square b by kt, and b is mu naught h. H in numerator and denominator gets cancelled. So we get mu naught n m square by 3 kt, and we substitute chi is equal to c by t. So we say that chi is inversely proportional to temperature. It depends on T and it is inversely proportional, where C is called a Curie constant, and this C is mu naught m square by K. C is a Curie constant. The equation that we derived is chi is equal to C by T, and this is the final expression. So here, so you observe that there is a positive value of chi. Chi is positive, ಇಲ್ಲಿ negative ಬಂದಿಲ್ಲ, chi is positive. So this is the basic characteristic of paramagnetic materials. In diamagnetic materials we got chi negative sign ಬಂದಿತ್ತು. So that is negative sign ಬಂದ್ರೆ diamagnetic, positive ಬಂದ್ರೆ paramagnetic ಆಗ್ತಾ. And also there is a dependence on temperature. Chi is equal to C by T ada. So T is absolute T is chi, that susceptibility depends on temperature. So there is a temperature dependence. So this is again a characteristic of paramagnetic. Okay, thank you.